population bottlenecks. This is actually one of my favorite topics to think about in evolution, since there are some pretty neat examples of bottlenecks. But I'll go into those specifics later. For now, let's go over the concept of natural selection. So if you have a member of a population that has a special trait, like being really strong, then that person's more likely to live to an age where he or she can reproduce and pass on that special trait to offspring. But you should know that as times change, so too does the specialness of a trait. The desirability of a trait is not constant. Let's say that a new predator comes into play in our population here, and that can overpower even our strong people. Maybe now someone who's tall is more likely to survive than someone who's strong. If you're tall, you have longer legs and can run a lot faster. And since these new predators are too tough to fight off, the people that are best at running away are more likely to survive. So now our tall person is most likely to survive, and he'll reproduce and pass on that trait and have lots of tall offspring. Now also keep in mind that populations are usually bigger than just two people. And this is great for a population because it means that there are lots of traits in the gene pool and they can all adapt differently to changes in the environment. The more traits in the gene pool, the more likely the species will survive what we usually call environmental stresses. Now, sometimes these environmental stresses can be massive. So massive that they almost completely wipe out a population. If you were to make a graph looking at a population size over time, you'd see a huge dip from this environmental stress. And we call these population bottlenecks when the stress wipes out so much of the population that only a tiny fraction remains. And we use the word bottleneck because we imagine that we have this bottle, and all of these blue beads inside will represent different people in the population. And because the neck of the bottle is so narrow, only a couple of beads will make their way out. Just like an environmental stress that's significant will only let a few people survive. So there are generally two outcomes that usually result from a big environmental stress. Either the population can't adapt to the change and goes extinct, or somehow the population recovers from that stress and can build up its population again. And we call this a bottleneck. So let's look at an example of each outcome. So first we'll look at an example where the population couldn't adapt. Now we all know that a long time ago dinosaurs ruled the Earth. Well, scientists think that one day a giant meteor came crashing down to the Earth and went kaboom and completely can change the environment that the dinosaurs were living in. So in this case, the meteor and the changes to the environment that it made was the environmental stress. And the dinosaurs just couldn't cope with the change, and they all died and went extinct. Now let's look at an example where a fraction of the population survived the stress. And this is the story of the peppered moth. So in the mid-1800s, there was an area of land with two populations of the peppered moth. One of them was white-colored, and the other was a much darker black color. Now the trees in the area were also white, and when the moth's predators, which were birds, came looking for moths to eat, the moths would hide by attempting to camouflage themselves on the trees. And naturally, since the trees were white, the white moths were much better at doing this than the black ones. And as a result, around 95% of the peppered moth population was white, while only 5% of the peppered moth population was black. However, a few years later, the Industrial Revolution happened, and factories started to get built in the area, and they would release huge amounts of soot into the air. And this soot started collecting on trees and dyed them black. Now, because of the change, white moths couldn't camouflage themselves anymore, and birds ate a huge chunk of the peppered moths since they couldn't avoid their predators. But what happened was the small population of moths that did survive this change were the black peppered moths. The soot covering the trees is the environmental stress here. And what's so interesting about this example is that the population of moths did recover, but now most of the moths, 95%, were black since they could camouflage themselves on these newly black trees, and only a tiny 5% were white. And this is a great example of the bottleneck effect, since the overall genetic makeup of the peppered moth population completely changed as a result of this environmental stress. So now let's revisit our graph from before. If we have a cataclysmic event that kills a huge number of individuals in a population, the population will either be unable to cope with the change, and their population will drop to zero and they'll go extinct, or a small group will survive and the population can ultimately recover. So what did we learn? Well, first we learned that a bottleneck is an event or change in the environment that destroys a huge chunk of a population, just massacres the population. But we also learned that following a bottleneck, a population can either go extinct if they're unable to cope with the change, Or a small group can survive and the population will eventually recover. But it's important to remember that when a population does recover from a huge stress, like a bottleneck, the gene pools in that population will change significantly.